Well, once again, good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Today we're continuing with our study guide, and once again, reminder, to have access to the electronic study guide, there's a code, XQPSE, same one as yesterday. All right, so today we're going to get to the, hopefully finish up the rest of the study guide. If you were absent and you need a study guide, they're back here. Come grab one. All right, so with that said, that's taking us to problem number 9, I believe, which is this one. So, before I get there, though, look up, writing utensils down, quick recap. First parent function, oh my goodness, sorry. Is it zoomed in? All right, better. First parent function that we looked at was f of x equals x, straight line. F of x, then we went to x squared, look like this. Then we went to f of x equals x cubed. And from there we went to f of x equals, I showed you guys x to the fourth. That looks something like this with stuff in between. Look up, please, so you're going to miss it. So let me show you where we're at in the coordinate plane. This is my coordinate plane. Here's this one. Here's this one. Here's this one. All right, so I said, look up to the screen, please. Let me pause the music. When we got to this, I said, pay attention, look up to the exponents on the functions. Look at this exponent and look at this exponent. And I said, where does this one start? It starts down here and it ends up here. This one starts down here and it ends up here. Now, what kind of exponents are those, everyone? These are what? Odd. Where do they start? Quadrant 3, down here. And where do they end? Quadrant 1. Get off those phones, my goodness. My goodness, I'm going to send, let's see, Maya to slap people around, my goodness. Stay focused. Here goes. Next, I said, look at the exponent on this one and the exponent on this one. Where does it start? Starts here and it ends here. Starts here and it ends here. So what do we know? That these are even exponents. Do you guys see that? Yes. And where do they start? Quadrant 2 and ends in quadrant 1. Quadrant 2, quadrant 1. For those of you that have no idea what I'm talking about and you're just hearing me say womp, 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 here it goes. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So where does it start? Where does the graph start? 2 and ends in 1, 2, 1. And all of these are what? Positive. Positive. Tell your neighbor what happens when I change that to negative. Tell your neighbor what happens. Oh, good communication. All right, good. Yes, what happens, Brandon Doherty, when we do the negative? It flips it, so it starts it in a different spot. So for the odds, instead of starting at 3, they start at 1 and end down here. Start at 2, end down here, start at 2, and down here. And the the evens just flip to 3 and 4, 3 and 4. With that said, look up to the screen. Number 9, it reads, which is the graph of an even Question, if it's an even function, where does it start and where does it end? What quadrant? Yes, you need to, I want to see you write down this on the study guide for me to see that you are actually understanding what you're writing. Even function, quadrant 2, goes to quadrant 1, from 2 to 1. Starts at 2, ends at 1. It's a what? Positive. I want to see you label that, because if it's negative, then you label it negative. So, look at the graph. Look at A. Where does this one start? At quadrant 3. So guess what? It's not A. Let's go to B. Where does this one start? Quadrant 2. Okay, so far so good. Where does it end? Quadrant 1. Okay, so far this could be it. Look at this one. Where does this one start? Quadrant 2. However, where does it end? Quadrant 4, so this is not it. Where does this one start? Quadrant 3. We need quadrant 2 to quadrant 1. Correct answer is D. This is what I want to see on the part C next week. I want to see you label all of that. Okay? Let me send you the screen so you can send me your notes. All right, here we go. Number 10. It reads, graph f of x equals x cubed plus 6x squared plus 9x. So, here we go. To graph this one, this is the work that let it go, let it go. Let's write the function on the side. F of x equals x cubed plus 6x squared plus 9x. Well, the first step is that we need to change f of x to what? 0. X cubed plus 6x squared plus 9x. Now, in order to graph a polynomial function, we need all the factors, don't we? So, first of all, look at it. What is the first thing we check? That it's in standard form, yes. Second, is there a GCF? Tell your neighbor what the GCF is. What does each term have? An x. That is correct. And that leaves us with, if we took away the x squared plus 6x plus 9. Can we still factor in here? Tell your neighbor how to factor that. 10, 10, 10, 10, 10. That is correct. 9 and 6. What factors of 9 add up to 6? Jacob squared, go. Yeah, 3 and 3. So my factors are x plus 3, x plus 3, and x equal to 0. What is our next step? Tell your neighbor, next step. What do we do next, Rylan? Put them up to 0. X equals to 0, x plus 3 equal to 0, x plus 3 equal to 0, and solve. This one's already solved. This one, minus 3, x equals negative 3, minus 3, x equals negative 3. So, these are my roots, my x-intercepts, and so on and so forth. Solutions. All right. So let's analyze this. Let me pause the music. Look up to the screen. What's the highest degree in this polynomial? What was the highest degree? 3. Is that correct? Which means, where should it start in our graph? It's an odd. It starts at what? Quadrant 3, and it ends in what? Quadrant 1. That is correct. So this graph should start at 3, and it ends at 1. But first, let's plot our intercepts. Our intercepts are 0, negative 3, and negative 3. How many negative 3s? 2 of them. So let's see. Start at 0. Here's 0. Okay, we got this. Negative 3. And negative 3, what do? We make it bigger. Why? Remind your neighbor, why do we make that a bigger point? To remind us to do what? Remind us to bounce off of it. That is correct. We don't go through it, we bounce off of it. So let's see. We start at 3. Did we start at 3 on this one? Did we end at 1? Yes. Is it bouncing off that first intercept? Yes. Did it go through 0? Yes. Well, without even checking the rest, this is the answer. Woo-wee. Let's go. We got this. Send me your notes. Shall we continue? Number 11. Here we go. Look up. Math says, which is the graph of the polynomial? Well, first things first, we need to rewrite this, but equal to what? 0. So do that on the side. And if you guys notice, they already did the work for us. They already factored it. So we're going to write 0 equals x minus 1, x plus 1, and x minus 4. Tell your neighbor what to do from there. What do we do from there? Go. Set them equal to 0. X minus 1 equal to 0. X plus 1 equal to 0. X minus 4 equal to 0. And we solve. Here we go. Plus 1. X equals 1. Minus 1. X equals negative 1. Plus 4. X equals 4. Once again, these are my x-intercepts, roots, and so on and so forth. By the way, how many are there? 1, 2, 3. Yes? Why do we need that, Mr. Q? Well, what is the parent function if it wasn't factored out like that? F of x equals x to the third, because there's 3 of them. So what kind of polynomial is this? It's an odd, and it's a positive. So where shall we start the graph? Quadrant what? Quadrant 3, and it is in quadrant 1. So let's look at those graphs. Which one starts at 3 and which one ends at 1? B and D. So not this one and not this one. We already eliminated those. So now let's check our intercepts. 1, negative 1. Let's see, 1, negative 1. And then positive 4. No, not this one. 1, negative 1, positive 4. Correct answer is B. Woo-wee. Man, cake. Right? Let's go. Send me your notes. From 1 to 5, how comfortable are we so far? We're getting there, right? You're like, Q, give us 3 of these finals. Let's go. Go to number 12. Which of the following polynomial functions would have the graphs shown? All right. Go to this one. Look up. First, let's identify our intercepts. This is what I want to see on your study guide. And on the final, look up. Start here. What is the x-intercept? Negative 1. So you do it once. Did it go through? Did it bounce off? So make it thicker. Bouncing off, so it's thicker. And then 2. And then 5. So let's write them over here. X equals negative 1. X equals negative 1. X equals 2. And X equals 5. Now notice I started down here and I didn't start at the top. Why, Mr. Q? Because now we're going backwards. Look at the work that we did on the previous one. Or the previous one. We're down here. If we go backwards, we need to end up with an equation, or at least something that looks like this. So therefore, what was it before we did this? Right? X plus 1 equal to 0. X plus 1 equal to 0. x minus 2 equal to 0, x minus 5 equal to 0. Next, what was it before it was like this? Before we set them equal to 0, what would have been the previous step? X plus 1 parentheses, x plus 1 parentheses, x minus 2 parentheses, x minus 5 parentheses, and all that equal to 0. Are we there so far? Do we have any repeated factors? Yeah, these two, right? Can we rewrite that? Yes, Mr. Q. X plus 1 squared times x minus 2 times x minus 5. Once again, we're working our way backwards. So, now that we're here, look at the options that they give us. What are the options? Let's see, which one has the x plus 1 squared? X plus 1 squared, not this one. Not this one. Especially not this one, that's a negative. Correct answer is D. (13), same process as what we did for number 14. I'll give you a head start. Go. All right, I gave you guys a head start. Here goes the process. Look up to the screen. We start off by labeling our x-intercepts. We got -2. We got 1. Check it. Does it go through? No. Does it bounce off? Yes. Make it bigger. There it is. So let's write them out. X equals -2. X equals 1. X equals 1 twice. Okay. From there, what was it before it became this? Oh, it's x plus 2 equal to 0. X minus 1 equal to 0. X minus 1 equal to 0. So far, so good? Next, what was it before that? They were factors. X plus 2, x minus 1, x minus 1, and all that equal to 0. And it looks like they have them like that, so you check which one has x minus 1 squared. In this case, they did not write it to the second power, and it looks like correct answer is D. Hands if you got that by yourself. Let's go. All right, let's move on. Make sure you send that in. Number 14, graph the parent function f of x. I'm sorry, the graph of the parent function f of x equals x squared is given. So our parent function is right here. Let me label that. Make sure you label it as well. This is our f of x. There it is. So according to this, look at the transformation. The transformation they give us is, I'm going to write it big so you guys can see it. It's parentheses x minus 4 squared minus 3. So, what happens to this according to that? Tell your neighbor. What happens? Where do we go? Where do we move the whole thing? All right. Jacob, squared. Where do we move the whole thing? Right 4, down 3. That is correct. Or in other words, look up. This vertex is 0, 0. The new vertex is what, everyone? 4, because there's 4 to the right, -3. So let's look for this, 4, -3. Let's see. 4, -3. Okay, this could be it. This one, no. This one, 4, +3, no. This one is 4, and it didn't even go this way. So the correct answer is A. All right? Now, these transformations are becoming a lot easier because we've been hammering these on the warm-ups a lot. And plus, we've been covering all this kind of movement with all the functions. Go to number 15, and it reads, solve the polynomial equation by factoring. So let's do this one together. Here we go. Let's write it again. -2x to the 5th minus 14x to the 4th minus 12x to the third equal to 0. So they're asking us by what? Factoring. We need to solve that by factoring. So, first things first, is it in standard form? 5, 4, 3, yes. Is there a GCF? Tell your neighbor if there's a GCF. And what is it? What do all of them have? An x? Do they have an x squared? Yes. How about an x cubed? Yes. X fourth? No, just x cubed. Okay, that's one thing. What else do all of them, can we divide all of them by? A 2, but since this one has a negative, we're going to say that it's negative 2. Negative 2. So, negative 2 divided by negative 2, that's 1. We took out x cubed, so we're left with x to the second. What is negative 14 divided by negative 2? Positive 7, yes? And we took out the x cubed, so that leaves us with 1x. Negative 12 divided by negative 2, that's positive 6. And we took out x cubed, so no variable there. So far, so good? Can we still factor inside of the parentheses? 6 and 7. Factors of 6 that add up to 7. 6 and 1. So my factors are x plus 6, x plus 1. Bring down the negative 2x cubed. And all that equal to 0. Tell your neighbor what to do from there. What's the next step? All of them equal to 0. Negative 2x cubed equal to 0. X plus 6 equal to 0. X plus 1 equal to 0. Let's solve. I'm going to start with this one. Minus 1. X equals negative 1. Minus 6. X equals negative 6. Divide by, let's see, by negative 2. X cubed equals 0. Divide by negative 2 is still 0. That means x equals 0. Because there's 0 cubed. So look at the answers. These are our roots, x-intercepts, and so on and so forth. So let's see. These only have 2, so it's not C or D. Correct answer is A. All right, send me your notes. Hold on. All right, let's go to 16. And it reads, how many roots, including repeated roots, does the function p of x equals negative x cubed minus negative 0.5x cubed minus 1.5x squared plus 4x minus 2 have? Now, writing utensils down, look up to the screen. Look at this one. This one is actually too easy. Let me repeat that again. Too easy. Look, all they're asking for is how many roots are we going to get? So question, what is the highest degree? So you need to write when you get here, highest degree. That's going to remind you that that's how many they have. So tell your neighbor and point out to your neighbor what you're going to circle from the polynomial so that you know that's the highest degree. What are you going to circle? I see everybody motioning to the 3. Yes. Circle the 3, point to what you wrote down, and guess what? Answer is D. So, right quick, look up. Let's say I gave you another polynomial, q of x equals x to the 23 plus 4x to the 15 plus 5x to the third minus 4x plus 5. Tell your neighbor what? How many roots does this polynomial have? 23, Michael Jordan. That is correct, because that's the highest degree. All right, I don't need a picture of this one. We got it, right? Let's move on. Number 17. What are the complex roots for this one? Whenever you get to this one, first things first, let's rewrite it. Bring this one down and set it equal to 0. So 0 equals x squared plus 1. X squared plus 1. And then we just need to solve for x. So what do I do from there? Tell your neighbor. Then Brandon's going to enlighten us. What do we do from there to leave x by itself? What do we do from there? All right, Brandon, Darty, what do we do from there? Subtract 1, that is correct. Negative 1 equals x squared. What do we do at the end, Brandon, Felix, to leave x by itself? That's right, square root. This cancels that. Oh, what is square root of negative 1 plus minus what? Tell your neighbor. Plus minus what? What? Is there such a thing of a square root of a negative? No, so this is what? I. That is correct. Imaginary I. We have a positive and a negative. Correct answer. Not A, not B, not D. Correct answer is C. All right. All right, number 18. Here we go. It says, find the roots of the polynomial. So first things first. Rewrite it, but set it equal to 0. So 0 equals 6x squared minus 12x plus 78. Now, this one is going to require a little bit of work, and then let me tell you why. So first things first, is it in standard form? Yes. Is there a GCF? Yes, you can divide by 6. That leaves us with x squared minus 2x plus 13 equal to 0. All right, next, can we factor the inside? Let's try it. 13 and negative 2. Question, what two numbers multiply to give me 13? Just 1 times 13. Question, can we add or subtract these two numbers to give us negative 2? Let's see, 1 minus 13, that's negative 12. No. Negative 1 plus 13, that's 12. Both negatives gives us negative 14. Both positive give us 14. So there's nothing that's going to allow us to factor it. So what do we do next, Mr. Q? Well, if it's not factorable, what did I ask you to do in the past? Your favorite? X equals minus b plus minus square root b squared minus 4ac over 2a. So in case you forgot, let me write the standard form equation underneath here. Look up. Ax squared plus bx plus c, and all that equal to 0, so that you guys remember this is the standard form. So here we need what? We need a. Say, neighbor, what a is according to this top one. A is what? 1. That is correct, because there's an invisible number here in front of the x squared. What is b? Negative 2. And what is c? 13. All right, now that we have our values, let's write this again. X equals minus parentheses plus minus square root parentheses squared minus 4 parentheses parentheses over 2 parentheses. So b, we said it was negative 2, so that goes here. Let me use red for that. Negative 2, negative 2. For a, I'm going to use 1, goes here and here. And c is 13. There it is. All right, so let's simplify. Here it goes. X equals, what is negative times a negative here? Positive 2 plus minus square root. What is negative 2 squared? That's positive 4. Negative 4 times 1 is negative 4 times 13. That's negative 52 over 2 times 1 is 2. So far so good? Yes? All right. Next, I'm going to go this way. We got 2 plus minus. What is 4 minus 52? That's negative 48 over 2. So I need to still take the square root of 48. So what two numbers multiply give me 48? 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. Which one of those has the biggest perfect square number? This one? No. No. This is the perfect square. This is the perfect square, not this one. The biggest one is what? 16. So I'm going to write this like this. 2 plus minus square root of negative 3 times 16 over 2. I'm going to continue over here. X equals 2 plus minus square root. Oh, sorry. Before I forget. What is square root of 16? 4. So that goes outside. Square root of negative 3 over 2. And last but not least, can we simplify these two expressions right here, the 2 over 2 and the 4 over 2? Yes, Mr. Q. What is 2 divided by 2? 1 plus minus. What is 4 divided by 2? 2. Square root of negative 3. Now, there was a typo on this one on the answers, so I don't think there's any of the answers that matches that, but there's one that's close. Tell your neighbor, which one would you have chosen from those 4 possible answers? Which one would you have chosen? Yeah, the one that comes close is C, except for it needed the negative inside with a 3. Is that correct? Yes, Mr. Q. All right. So just keep that in mind. But here goes once again, just to recap. Set it equal to 0, GCF. Try to factor using Power Rangers. If you can't, you go to the quadratic formula, substitute values, and the rest is history. And this is for number 18. Number 18. All right, send me your notes. Number 19. It says, identify the asymptotes, domain, and range of the function. And for these, if you focus on the asymptotes, you're going to be fine. So look at this one. Let me zoom in. G of x equals 1 over x plus 7 plus 3. So this is what I want to see on the pop parte. You write on the side, VAX equals HAY equals. Why is that, Mr. Q? Because muscle memory. We've been doing these. As soon as you write that down, you're going to look at the equation and write the numbers that you need. Tell your neighbor what the VA is and what the HA is. What is our VA according to this? VA is -7, and our HA, 3. That is correct. And then just go looking for those two. Let's see. Let me zoom out. VA, -7. Which one has -7? This one. Which one other? This one. Okay, so not C and not D. Which one has the HA of 3? Let's see, this one is negative 3, so it's not A. Correct answer is D. Woo-wee. How about them apples, yeah? All right, let's go. Number 20. Let's go. It reads, let me zoom in. Rewrite the function 2x minus 5 over x minus 3. So by looking at it, look at it. Can we rewrite it to look like that? Yes. Tell your neighbor what to do to make it look like that. What do? Look at it. Whenever we don't have a 1 on the numerator, what do? Long division. So for number 20, when you get there, just write long division. So like that, you remember to divide this. So let's do that. 2x minus 5 divided by x minus 3. All right? Let's see. Help me out. Mitos, what number times x gives us 2x? 2. That is correct. So 2 times x is 2x. 2 times negative 3 is negative 6. Yes, sir. Subtract. Look up, please. Don't forget, whenever you're doing the subtraction here, circle it so you remember to distribute here and here to both. That negative we're distributing. So this cancels, and we're left with 6 minus 5. What is 6 minus 5? 1 is our remainder. Okay? So help me write this answer. Tell your neighbor, how do you write the answer for this division? How do you write the answer for that division? Yeah, we start with the answer, which is what? 2. But since we have a remainder, we need a fraction plus a fraction, which is 1 over x minus 3. Do we have a 1 on the numerator? Yes. But we have that 2 in the front. What do we do with that? Send it to what? To the back. So my new equation is g of x equals 1 over x minus 3, and then we move the positive 2 to the end. And then all you have to do is go searching for that equation. Let's go. Let's see. Which one has that 1 on the numerator? The only one is B. Ooh-wee. All right, send me your notes. Hold on. 21 reads, using the graph f of x 1 over x as a guide, describe the transformation for this one. So this is what I want to see. Look up, please. When you get to this one, write this one somewhere. F of x equals 1 over x. And right below it, write the transformation that they gave you. G of x equals 1 over x plus 3. So, by looking at it, and let me remind you, this is our general rule. Our general rule was g of x, a, then we got parentheses 1 over x minus h plus k. I'm not even using b for right now. But looking at it through that lens, does it move it to the right or to the left? Look at it. Is there anything next to the x? No. So what does the 3 do, everyone? It moves it up 3 steps. That is correct. So A says to the left, no. Down, no. Up, yes. Right, no. So the correct answer is B. Once again, make sure you write them like this, one on top of the other, so you can see exactly what's going to happen to the original one. Parent function. Let's go to 22. Identify the zeros. Oh, yeah. So, let's write the equation on the side again. G of x equals x squared minus 4x plus 3 over x plus 2. Now this one, again, they're talking about zeros. Don't worry about the zeros. Let's do the work that I asked you to do. First of all, are they asking for a whole? Let me ask the question again. Are they asking for you to find the whole? No. So we're not worried about factoring. What are we worried about, Mr. Q, if we're like this? Long division. Long division. Here we go. X squared minus 4x plus 3 divided by x plus 2. All right, Vianney's going to help me with this one. Vianney, what number times x gives us x squared? X. X times x, x squared. X times 2 is 2x. We're going to subtract. Distribute. We're left with negative 6x. Bring down the 3. Positive. What number times x gives us negative 6x? Negative 6. So that is negative 6x, negative 12. Subtract. Distribute. Here, cancels. And we're left with 15. So, how do we write this answer, guys? Here it goes. Look up. The answer for this division is x minus 6 plus there's a remainder of 15 over x plus 2. Question, can we have that 15 on the numerator? No, where do we send it? To the front. That is correct. Can we have the x minus 6 in the front? Where do we send it? To the back. So we have at the end g of x equals 15, 1 over x plus 2, and then at the end plus x minus 6. We're almost done. VA x equals is negative 2. HAY equals x minus 6, which is this. So it's going to be an equation started at what? At negative 6. So let's look at these. Which one has the asymptote at negative 6? Let's see. Hold on. Negative 6 is about right here. Let's see. Is there an asymptote going like that? Yes. How about this one? No. This one could be. This one? No. So these are the two possibles. However, what was my VA? Negative 2. Which one has the VA at negative 2? Let's see. Do both of them do? Negative 2. Oh, sorry. Negative 2 is of x is over here. Nope, not this one. Is it this one? Yes, correct answer is A. So, before you leave, take another study guide. Go to the YouTube channel. I'm going to finish up the last two with the other class. You should have the video of all problems worked out. Have a good one, guys. Study over the weekend. See you guys till Monday. Bye.